Hey everyone, today we are going to talk about relations and functions day 2. If you have not printed off the note sheet for today, please do that before you proceed with the rest of this video. Okay, so we are going to talk about specifically domain and range today, and I didn't use those terms in yesterday's lesson, but I am going to talk about them today. Your domain, whenever you hear the word domain, those are all of your input values or your x values of a function. Your range is all of your output values or your y values of a function. Now, every function that we talk about, you can kind of think of it as a function machine. It has an input, the machine does something in here, and then it spits out an output. So your input are all of your x's, your outputs are all of your y's. So if you think of a table of values, you have x's and y's in your table. Your x's are your inputs, your y's are your outputs. So let's say my little function machine here takes whatever value it has and then it doubles it. So I'm going to say that my function here is 2x. That means for whatever x value I put in, I'm going to double that and it's going to spit out a y value. So for example, if my input value is 1, my output value would be 2. If my input value was 2, my output value would be 4. Okay, if my input value was 3, my output value would be 6. And I could keep doing that. This is called the rule of your function. So whatever that rule happens to be, that's how we figure out what the output is based on our inputs. And so if you look at this table, and I could fill out the rest of this table, right? All I would do is for every x value, I would just double it to get a y value. And I'll just go out to here to 5, and we'll stop there. All of these values over here, all of these are my domain values, and all of these are my range values. So if I ask you to state the domain, all you would do is list them. So my domain is 1, 2, 3, 4, and 5. My range would be 2, 4, 6, 8, and 10. Notice I'm only listing the values that are actually in my table. But if you just remember that your domain values are all of your input values and your range is all of your output values, it'll be very easy and straightforward for you. So let me show you, based on the type of example we have, how we would determine our domain and range. If you are given a list, like in example 1 here, this is like what we did yesterday when we listed them out. We said we looked at the set of ordered pairs to determine whether or not it was a function. This is a function. If you notice, there are no repeating x values. And so if I want you to state the domain and range, all you're going to do is like we just did. Remember, your domain are all of your x values. So my x value, I've got 1, I have 2, I have 5, and I have -3. Remember, your x's are the first coordinate, so that one, that one, that one, and that one. My range values, I'll change colors here. My range values are all of my y's, so that would be this one, this one, this one, and this one. So my range values would be 3, 4, 7, and -1. That's all you have to do to state the domain and range. That's when you have a list of ordered pairs. Let's look at it if you have a table. Just like we did in the very beginning of the video here, remember our domain, I'll try to keep my colors consistent here. My domain are going to be all of these values. So my domain here is all I'm going to do is list them. -1, 2, 3, and 4. And my range are going to be all of these values here. So my range is -5, 4, 7, and 10. When you have a mapping diagram, it tells you right here, and we said this yesterday, that the left part of the mapping diagram is always your x values, the right part is always your y values. So this is your domain over here, and this over here is your range. So again, all I'm going to do is to state my domain, I'm just going to list out my values. So I have -2, 2, 4, 5, and 6. And for my range, I have 4, 16, 25, and 36. Those examples are pretty straightforward. Now, the graph is going to be slightly different. In all of these examples that we already did, we have individual values that we're listing because we have them listed as individual numbers, right? And here these are individual numbers. In our table, they're individual numbers. In our mapping diagram, they're also individual numbers. However, if you're looking at a graph, what you want to do is look at all of the possible x values that fall into the graph, and then look at all the possible y values that fall into the graph, okay, that are in the graph. So for your domain, you want to figure out what all of the possible x values are. Remember that for domain, for x, you're seeing how far it goes this direction and how far the graph goes in this direction. Because there's an arrow on the end, I know that my graph goes on forever and ever in the negative x direction, and it goes on forever and ever in the positive x direction. So my graph goes from negative infinity to positive infinity. Okay, my graph goes from negative infinity to positive infinity. My range are all of my y values. So I have to figure out how far down on the y-axis my graph goes and how far up on the y-axis my graph goes. Well, this is as far as it goes. It only goes down to -3. So the lowest my graph goes is -3. The highest my graph goes, if these arrows means that it goes on forever and ever and ever and ever, that means y can get larger and larger and larger, which means that it can go all the way to infinity. And that's how you would write out the domain and range of a graph. We are going to do graphs in a lot of detail in class tomorrow. I just wanted to give you a precursor to that. But right now I want you to focus on domain and range, listing them out when you see problems like 1, 2, and 3. Your homework is going to focus on problems like 1, 2, and 3. I just wanted to give you an example of what a graph might look like. Like I said, we'll talk about those more in class tomorrow. Okay, everybody, thank you. Take care. Bye-bye.